Hi everyone, my name is Pedro Cruz. I'm a developer advocate at IBM, and today we're going to be talking about Call for Code Bootcamp. So this is actually a new initiative that we're doing to help people who are maybe not yet experienced in development and want to participate in Call for Code. You need examples, you need tutorials, you need things to be able to learn. So in Call for Code, we have many different themes. We have artificial intelligence and machine learning, data science, we have IoT or Internet of Things, we have the cloud, you need to deploy your application somewhere. So all of these different topics, we have tons of resources on our website. Today I'm going to be showing one specific example that you could use as a starting point for machine learning applications. It's based on my previous work on DroneAid. So I'm going to be sharing my screen and be showing you the repo. So if you go to github.com, call for code, and go to the DroneAid repo, right here you'll be able to see that we have an example of an application that uses one, machine learning. Two, you can even connect a Tello drone. This is a very small, even toy drone that's used for education. You can use machine learning to be able to get the feed and detect things with it. So let me just give first an overview of what DroneAid is. So here in the repo, there's a video that you could watch. That's me a few years ago without the beard in the first Call for Code hackathon. And essentially, the short story is in Puerto Rico, there was a huge hurricane that wiped out all of our electricity and communications. I personally was without communications and electricity for about 6 months. So I started thinking about a way that we could communicate after a natural disaster. Not only hurricanes, but also earthquakes, floods, and any other disaster that takes out the communication infrastructure. So at the time, after Hurricane Maria, I was helping nonprofit organizations document the damages. And I was flying my drone and I noticed various SOS messages. So the idea was be able to make a standardized language for SOS and other symbols. And these are based on the United Nations Office for the Coordination of Humanitarian Affairs, so OCHA. And these symbols are meant to be able to use in any language. So the idea is after a disaster, imagine if there's an automated fleet of drones that could go over an area. And if someone draws on the floor this symbol, SOS, or let's just say in an area where there's a heavy drought, someone decides to draw this water symbol. These automated drones could collect that information and send that to first responders. So we have many contributors in the DroneAid project, and we have created various tutorials. So the first thing that I'm going to show you is how exactly does the training work. And thanks to Nick Bordakos, we have a very simple tool to be able to train machine learning models. And this is the tutorial that was prepared. Shout out to Nick. Very easy to use. It uses the IBM Cloud. And I'll leave the link up in the stream and also maybe in the chat as well. Here in this tutorial series, you'll be able to see how exactly you'll be able to train a machine learning model in the cloud. So the first step, as we see here, is to collect your training data. So this data, and even before getting started, I recommend you're going to need a IBM Cloud account before you get started. So make sure you have an IBM Cloud account. Afterwards, then you can go to cloudannotations.ai, and this is the interface that you'll be using to upload your data set and do the training. So after logging into the IBM Cloud, you need to create a cloud object storage resource. So this is where all your data is going to live. After that's created, you'll import that in Cloud Annotations and give the bucket a unique name. So for this tutorial, we're going to be showing you how you can train a localization model. So for those who have never heard of this before, basically localization is able to recognize specific objects on the screen or in the video stream. So for example, imagine you have a machine learning model that's able to detect cars on the street. This is very important for self-driving cars. They need to be able to detect people, road signs, other cars, trucks, bicycles, everything. So not only do they need to detect it, they also need to localize where it is and do the tracking. So this type of model can be easily trained inside of Cloud Annotations. So throughout this tutorial, you'll be able to see what is the best type of data to be used. I recommend for it not to be very blurry, but also the data set should have different orientations of the same photo. So if you have never played with machine learning before, don't get too worried. This is not complex. I recommend just look for 50 training images. So this 50 training images is going to give you a result. It will probably not be the best result, right? The reason is the machine learning algorithms leave a lot more examples to be precise. So for this to be a model for production, right, to be used in the real world, I would recommend thousands of images. But for the sake of time, of course, I recommend just going from 50 and then going up from there, depending on how much precision you want. Now, within this interface, you'll be able to see how exactly is the data labeled. So after you upload all of your images, you'll be able to draw bounding boxes around the objects. In this example, we're tracking cars. So everywhere where there's a car, we're going to draw a bounding box. And we're going to tag it. If you want to detect multiple objects within the image, you would have to give them separate names, different tags. So just in case, if you need sample training data, you can actually download some from here. And then afterwards, we have a few different tools. For this tool, we're going to be using Google Colab. It's a great, easy interface that's free, and we're able to train our models quickly. I was able to train a model within 20 to 30 minutes. After we do the training, then we're going to download it, and this is where you can bring your model to life. You can either choose a React web app, an iOS application, Android, Livestream, Raspberry Pi, or Python. For this tutorial, we're going to be using the React web app. So I'm going to now share the third link. This will take you to the GitHub repo where you're able to download or clone the React sample application. So it's a very simple app. And before we get started, let me just give a quick demo. So I'm going to get my phone over here. I'm going to be streaming a view of my phone, and I'm going to be using the model live. So I've already downloaded the project, have done the training. So give me 1 second so I can raise the font here. And then I'll give you an overview of how the React app works before getting back to the Cloud Annotations. So let me just find here an example. So the good thing about DroneAid and the template and the project is that you don't have to use it for detecting SOS images as the example shows. This is a very powerful tool because you're able to use it in different scenarios. For example, after the hurricane in Puerto Rico, there was a 6.4 earthquake. And I remember waking up around 4 a.m., being shaken in my bed, and it was shaking for about 30 seconds. Afterwards, there was a sequence that is still going on. So we receive a lot of earthquakes in the Caribbean. After the earthquake, there were many places on the island that were showing damages. These are old buildings that were not up to the regulations and up to the code. So the plan of using DroneAid is that imagine you can have a drone go into a facility that's vulnerable, that's about to collapse, and do inspections. Using machine learning, you can detect precisely what type of cracks and how vulnerable the building is. So let me just get the window over here, make sure I have the example. Okay, so I'm going to, oh, sorry about that. So here on the left, I have the web application. On the right, I have some sample images from Google. So I want you to focus on the left. I'm going to get closer. And as you can see, we can detect different types of cracks. So this, for example, is one of the most dangerous ones. It's in a form of an X. But as we go down, we'll see that other types of cracks can be detected. So let me see if I can find another one. Okay. So it's showing a lot of X. So what that tells me is that maybe the model is overfitted. Maybe it's detecting everything as an X. In this model, I have chosen 4 different types of labels. So just wanted to give you a demo of how things will work. Let's jump back to the Cloud Annotations so then we can see how this model is trained. Okay. So back over here to the tutorial. Now, once again, make sure before getting started, you have an IBM Cloud account, and you also follow the instructions here to be able to get your cloud object storage run. So this is very important before you get started. So after you get all this set up, you follow the instructions on the screen, then you can go to Cloud Annotations, which you can see here, and you can start a new project. So I'm going to just give a really brief example on how you would start a new project. Go here to the button after connecting the storage bucket. And I'm just going to call this a damage check 3, very original. Hit confirm. And now, since we want to be able to not only detect the type of object that's on the screen, right? That's classification. We also want to localize it. We also know where it is. So I'm going to select localization. And as you can see here, we have now an empty bucket. We can now drag and drop We can now drag and drop images. So I'm just going to get a very random image. Let's actually get it from Google. So I was looking for a earthquake damage. Okay, so this is just an example, but I recommend take some time, organize your data set. I've already trained this model, so you don't have to follow my exact instructions here. So I'm going to go ahead and put here earthquake sample. And let's go back to Cloud Annotations, and you can just drag and drop and upload it. So once you have uploaded your images, you can then start with the tagging. So in this case, let's just say I was wanting to detect the faults of the construction, or maybe there's debris on the roads, and there's a self-driving car that wants to be able to detect this debris. Whatever your use case is, all you have to do is select the object you want to detect. Let's just say these pieces of concrete. So I would select it and draw a bounding box around that object. On the right here, you'll see we have untitled label. So we're going to click on the edit button, and we're just going to call this concrete. And then you would continue. So let's just say you want to detect all little pieces of concrete in the image. You will continue labeling them until you have everything off on the screen. So I'm not going to continue in this image, but I recommend getting some coffee or some tea with your 50 to 100 images, and you're going to go one by one drawing the bounding boxes. So how would that look like at the end? Let me go back to a previous project so you can see how it looks like. So the model that you were seeing earlier is this one. So in here, you'll see that I have a total of 115 images. I have 4 different labels: vertical, horizontal, diagonal, and X. And that represents the type of damage that's been shown in the concrete. So here you'll be able to see the different type of damages, their labels, and this is what the final product will look like. Okay. Afterwards, once you have labeled everything, you're going to go hit this button where it says Train and Collab. So once you hit that, you're going to see your API keys. Remember to keep this secret. Don't share it with anyone. You're going to copy them, and you're going to make sure you can paste them in the Google Colab notebook. So before we continue, if you have never done machine learning training before, essentially one of the best tools and the most common one is using what's called notebooks, Python notebooks, Jupyter notebooks. Essentially, you can run Python code with inside of a very easy to use environment. This specifically that I'm using is called Collab, and you can even integrate. You can save your notebook as GitHub gist, or save the whole notebook in GitHub. You can also change the runtime type. For example, if you need higher power, you could use the TPU. So play around with that. For now, I'm just going to leave everything as is. So where it says here credentials, you're going to paste what you had earlier. So paste the whole thing. And now, let me just give a quick overview of what the Jupyter Notebook is doing. So here we have the setup. Then here you can see it gives you the instructions or the description of what each step does. So the first step is to install the TensorFlow Object Detection API. We are using TensorFlow behind the scenes. Next up is going to do a quick test. Then mount the Cloud Annotations bucket. That's why we need the API keys, so then we can connect to all the images that you have uploaded to the cloud. So once we connect to the bucket, we're then going to take the labels that you use when you were doing the bounding boxes and apply them to a label map. So in this case, we have like cat, dog, goldfish. In my case, I have X, vertical, diagonal, and then horizontal cracks. Afterwards, we're going to get a list of those labels, create the label map, and then generate the TF records. Once again, if you don't know what I'm talking about, if this is getting complex, don't really worry. Go through the code, try to understand what it's doing, and read the description. But it's not necessary to write any new code for this tutorial. So once we have all the labels and the annotations loaded, then we're going to take a base model. So one of the reasons why we use a base model is that these machine learning models take hundreds of hours, many times weeks and months to be able to train. So we want to have a pre-trained model that we can add a layer on top. And this is what this does. So here you'll be able to see that we're using the SSD mobile net architecture. So this allows you to have a very small size, allow you to do machine learning in the browser. So that's what this section is about. We configure the model, and then this is where the training starts. So specifically, we're going to be training for 100 steps or 100 iterations. These parameters can be changed if you need to. After the training finishes, we're going to export the graph. We're going to take all the data from the model, and then we're going to make it accessible to the browser by exporting it. So we tested, and then we were able to convert the model to something that the browser understands. And then from there, download it for our React application. So I am not going to run this since it is going to take a while. I have already done that. But for those who are following along or watching this to learn, just to train everything and get started, you have to press here, runtime, and then hit run all, or just use the shortcut. So after hitting run all, this is going to run. Expect at least 20 minutes. And this all really depends on the amount of images that you have. The more images, the more time it's going to take. So be wary of that. All right, so let's just say you were able to annotate your images, you're able to successfully train it, and you have downloaded your model to your computer. Then we hop over to the Object Detection React repo to do the clone. So I'm gonna now share here on the screen this link. This is the Object Detection React sample application, and you're able to get the model that you just trained and use it in real time, just as I shared earlier. So you're going to follow the instructions here. Make sure that you have Node.js installed, you have npm before getting started. And after you have cloned it and you have installed the all the packages, then you're able to get your TensorFlow model and add it to the repo. So let's open that up one second. All right, so let me see if I can find it. All right, so this is the folder. Okay, so make sure that you download or clone the GitHub repo that I shared. And then here, Google Colab is going to give you the model web zip. So you're going to open it up, and then you'll be able to see the data. So this is the raw data set of the model, the labels. So in this case, I'm showing here, this is SOS. So this might be a previous one, actually. So just a heads up. I have inside of here, model web, we have the correct labels. Yeah, there we go. So might be a little bit small for you, but it says vertical, horizontal, diagonal, and X. That's what I did earlier. So we can ignore this. I can just erase it, right? This model, once you download it, you're going to place it within here, the public folder. So going back to the GitHub repo and instructions, you'll see that we need to, once you run npm install in the terminal, you'll add the TensorFlow.js model to the application. You're gonna copy the model web, make sure you unzip it, right, before importing it. And then you're gonna paste it in the public folder, just at that directory. So that's what I did earlier. I took the model, I went to the public folder right here, and you see that we have an index.html, and we also have the model web. So once you have done all of those steps, then you are ready to get started with the running the application. So let me just quickly pause it. I'm using Visual Studio Code to run it, but you can use your favorite editor. And you'll see here within the source, we have various functions. So I'm not going to go too much in detail, but for those who are interested in modifying the code, using this as a template or adding to it, you can see that we have structured the code within here, the source folder. Specifically, all the magic or most of the magic happens within here, object detection video. So we have 4 different JavaScript files that are able to first detect the webcam, get the stream, do the prediction, and show it on the canvas itself on the website. All right, so once you have the model web folder within the public directory, that's all you have to do to run the application. To run it, You're going to make sure you're within the directory. So I am within here. And now I'm going to run, you could either run npm install, or what I prefer, yarn install, whatever your preference is. All right, so I had already done that. To run it, you have to do yarn start or npm start. Well, what that's going to do is that it's going to start the development server. So don't worry about this. There is a small little issue with that, with the camera, but let me just hit refresh here, and there we go. So as you can see, I am now, you don't have to do this. This will also work with your webcam or with any other camera, right, that you can access through the browser. I'm using a special application called Bootcamp, and I'm able to use my phone to stream the video. So as you can see, I could go around my house and looking for the different cracks on the wall. So right now, you can see it detected a vertical crack. But to be honest, that's not damage. So there's still a lot of work to do within this application, but this is definitely a really good example for you to get started. All right, so I'm going to close this now. And let's go back to the code. So that's pretty much it. We have learned how to prepare the data set, how to train the model, how to use Google Colab, and also run the React web application. Now, I really encourage you to just test out the React web app first. I think that's one of the easiest ones. The iOS and Android apps will require you to download the Xcode and Android Studio, get all the packages installed, so it might take a little more time. If you have a Raspberry Pi or you prefer to use Python, you can find these demos within here. So with that said, let's go back to the DroneAid repo. So if you want to take this to the next level, you could use a teledrone, and we have created a really nice interface to do testing where you can fly the drone and do the detection there. Apart from that, if you want to do training or see how exactly I trained the previous data set or model, you can go to augmented reality image training. So what I did here, actually, let me just go to another README. So setup.md. So this is the instructions if you want to replicate DroneAid completely. I personally use Snapchat. I know, surprisingly, I use Snapchat to be able to create the data set. So they have a software called Lens Studio. As you can see here, I use all the images that I want to detect. So SOS, water, etc. I place the symbols within this 3D virtual environment. So what this allowed me to do is to quickly create a data set using augmented reality. So if you're interested in this kind of stuff, or if you're curious on how to create a data set rapidly, I highly recommend that you go through this tutorial. And you can use the same type of format. This also works with TensorFlow.js. You just got to make sure that you train the model accordingly. So with that said, that's pretty much it for this first Call for Code Bootcamp series. Apart from DroneAid, we are also going to be going over other previous Call for Code projects. We have the Cluster Duck protocol, IsaacSimo, OpenEW, Pira, and more. So if you have not yet got started with Call for Code, with your project, the deadline is coming up. So you may not have time this year to participate in the Grand Challenge. However, we do have more upcoming challenges that are coming throughout this year. So I highly recommend you join our Slack group and you go to the Call for Code website for more information. So yeah, that's pretty much it from me. I just want to say thank you again for assisting the workshop. Good luck for all those Call for Code participants. We have about 2 weeks before the final submission deadline. If you have any questions about this specific tutorial or maybe your projects, feel free to reach out to us on Slack. We have multiple channels there about IoT, artificial intelligence, cloud. If you need any help whatsoever, we have a full team that can assist you. So with that said, thanks again, and hope you have a good day.